Day, welcome back to the intermediate tutorial series, lesson 21. We're going to be talking about scrolling today and some other junk. I'll get to that later. It's been a couple of weeks, been down with the good old flu. If you go back to lesson 20 and you listen very carefully, you can actually hear the virus particles, duplicating themselves in my cells. So yeah, but that's all done and hopefully out of my system now. If my voice sounds weird, well, I got a little bit of the cough left, but who am I kidding? My voice always sounds weird, so maybe it's an improvement. Hey, maybe I should get sick more often. Alright, so what are we gonna do today? Well, we're gonna do a couple things. I'm going to make a prediction. This episode is going to be about 2 hours long. And you might be saying, oh God, not another long episode. But this is going to be way easier on the brain than the last one. At least easier on my brain. Because it's easier to explain. This is kind of lightweight stuff. This is the fluffy stuff. These are the little marshmallows that you get in your Lucky Charms. I love those little marshmallows. Okay, so yeah. So we're going to be doing scrolling. And of course, we're not going to be doing it in like a kick-ass, chilly type way. We're going to make scrolling hip. We're bringing it back, people. But before we talk about that, I got a little extra bonus thing that we're going to do. And we got a little bit of housekeeping to do. So let's start off with the housekeeping. We start off eating our broccoli, and then we skip to the ice cream. So let's take a look at where we are at. So we got this dumb dude is running around. But what I don't like is I don't like that stupid rectangle. It looks like a freaking rectangle is sliding all over the place. I mean, that is exactly what is happening in our simulation, but I don't like to actually have it just hanging out there. We want to pretend like this is a dude running. It's not just a rectangle sliding around. So we're going to get rid of this, and that's going to solve that problem. But we got another thing, another little loose end that I forgot to take care of on the end of last episode, and that is in game. So let's take care of this. Here we go. So we're drawing all of the tiles that we're colliding with. But if you noticed, we're not drawing any of them anymore because we don't collide with them. Or we do collide with them, but then we correct that collision before we hit compose frame, so they never get drawn. So we can get rid of that because it is superfluous. And now that we've gotten rid of a bunch of other junk, let's go to sprite. And we don't need this anymore, motherfuckers. I told you I was going to get rid of it. Die. You ain't touching any of my privates unless I say so. Get rid of those accessors. Keeping our sprite class lean and mean. Look at this interface, man. Is that the most minimalistic interface you ever did see? I do believe it is. Keeping it simple. And not really simple. It's actually complicated. It's all under the hood, you see. It's like people. Like, you look at them, they're like a face. They're wearing a suit. But inside, there's all these like gutsy parts that are squishing and exuding and what's the word I'm looking for? I don't know what it is, but it's all nasty inside. People are nasty inside. Lots of juices. But you never see that. You only see the face and the suit. The shades. I gotta stop rambling. Okay, what was I doing? Okay, let's build this. Make sure I didn't fuck anything up. It's always good to not fuck shit up before you continue. And go, and of course it's gonna work fine. Much better without that ugly rectangle. So that's the cleanup part done for now. So part 2, we start scrolling, except we don't, because we're gonna take care of a little business before we start scrolling. Now, to do scrolling the way I want to do scrolling, we are gonna need a new class. We're gonna need a rectangle class. But it will be a rectangle of integers. That's right, a rect of ints, a rect I. And all we have is a rect f. So how do we solve this conundrum? Well, the most straightforward and obviously not the right answer, because I never like to do things straightforward here. You know how I run this ship. Would be to go project, make a new item, add a class called rectI, copy this bullshit, paste it in, replace rectF with rectI, replace all these floats with ints, and we would be done. That would be the easiest way, kind of, in a way. That's the way you would do it, but that's not the way I'm going to do it. We're going to do it with templates. We're going to make a template class, people, and it is going to be epic. Maybe not, but we're going to do it anyways, because I feel like this is a teachable moment. I normally don't use templates when I program. I feel they're more a thing that you need to use when you're like writing a library, like a general purpose library for people to use over and over again. They're kind of overkill for most situations, but I just felt it fit in so well in this situation. It's such a teachable moment. So we're gonna do it. We're gonna make it happen. Why does it not like this? Cannot open. Oh, I see what you did there. I see what you did there, you motherfucker. Delete it. Oh, I want to delete it so hard. Okay, let's try this again. For those of you who didn't realize, I fucked it up again. I did the thing that I wasn't supposed to do. And it's good. You see, this is actually the second take I did of this. And the first one I did perfect. I didn't do it perfect, obviously, because I'm doing a second take now. But I didn't fuck that part of it up. At least I got the assets folder right. Okay, so we start off with this for our thing. Everything's good now. And so we're gonna make, of course, we call the include file rect, so we're gonna call our template class rect. So we're gonna go find and replace rectF with rect in this document for now. Replace all 7 occurrences. That sounds good. Now, how do you make a template class? Template class is a class that has some part of its definition that is variable depending on a template parameter, I guess what you'd call it. So first you've got to say what your template parameter is. So you go template and class T. So T is the name of the parameter, and it's going to be a class. And just to be clear on this, class can include ints and floats and all that simple data, but it can also include, more complicated classes. So, template, class T, class rect. So now that we need a class, template class, and the template parameter is T. And that parameter is going to be a type that is going to be the type used to store the positions. So we say T top, T bottom, T left, and T right. So now the types of our variables, our member variables, are going to be T. What else? Well, just copy this. Obviously, when we initialize, we're going to want to initialize with T, type T, whether it be float or int or whatever. And yeah, that's about it. Done. That was fast, wasn't it? So yeah, that's how you make a template class. Now, obviously, things like rectF or whatever, rect by itself isn't going to work. It used to be rectF and rectF here, but I find and replaced it away. But yeah, rect by itself isn't going to fly. We got to do like rect float. I'll do this rectF list. If we did that, that would make this fine. See what we did here? We've got a template class inside of another template class. That's templateception. Am I cool? Can I still say that without being whatever. So now we've got our template class. What are we going to do with it? First, we're going to say, hey, rectf class, fuck you, shitbag. And we're going to go all throughout our solution. I'm going to find and replace rectf.h. Ah, you fucker. Oh, good. Came back with rect.h. Entire solution. Go. 3 times. Okay, so now we've gotten rid of all of our rectfs. And what do you think? What do you think it's going to be like? We got rid of all our include rectfs. Why is this still working? I have the feeling that this shouldn't be underlined in red. Let me go over here. Here we go. Yeah, here we go. See, it doesn't like it. Do not want, it says. Do not want rectf. What is? So this isn't good anymore. Rectf obviously isn't a thing anymore because we got rid of it. Now it's all about the rect, but it's actually all about the rect angle bracket something. So if we did this, it would be happy, but we'd have to do it here. Or, I don't know. We'd have to do it in lots of different places. Everywhere we see a rectf, we'd have to replace it with rectf float. That would be a pain in the ass. We could do find and replace, but I got a better idea. I got a way sexier way to do this. Because you know how I like it when it's so sexy. Oh. So we go down here. And we go type def. Rect float rectf. So we make a new type called rectf, and it's just basically rect with the template parameter specified as being a float. And so to be, I don't know, stop that. Consistent. Place that in there, and that works fine now because of course it's a thing. Rectf is now a thing. Go to collision rectangle. Now rectf is fine. Everyone loves it. They're loving it. So let's try to build a solution. Good build. Succeeded. Everybody's happy. Everybody's kung fu fighting. Let's just run it to make sure. To prove that I'm not, I don't know, pissing on your leg and telling you that it's raining. Is that the expression? Yeah, it works fine. Okay, so good. Templates work good. We like templates. Now, let's prove that they were worthwhile. We're going to go into this thing here because it's convenient. And we're going to go rect f r1 0.0f 1.0f 2.0f 3.0f. Good. Rect I isn't a thing yet. Let's make rect I a thing. We do that by going into rect and going type def rect int rect I. There. Now it's a thing. Rect I R2. That was not even close to R2. R2 0. Let's make this one 4, 5, 6, 7. So now we have rect I R2, rect I R1. We can do both of those things and they're all good. Integer rectangles, float rectangles. You can make a rectangle of anything as long as the operators fit. What else? Well, let's try this. R2, let's try rect I R2 is equal to R1. How does that work? No, it doesn't work. You can't assign a rect F to a rect I because they're two different classes. Even though they come from the same template, they're not the same thing. No suitable user-defined conversion from rect F to rect I. What does this mean? What is this user-defined conversion that you speak of? Blasphemy. Actually, you can make functions that automatically convert from one class type to another. And they're kind of cool. Some people say they're not good and you shouldn't touch them. They're black magic. But you know what? I say fuck those people. Fuck them in the ass. With a dragon dildo. Let's do it. Let's make it. Let's make a user-defined conversion function. How do you do that? Well, what you can do is you go operator, because user-defined conversions are operators, and then you type the type name that you want to convert to. So we're going to say we want a conversion function that converts into rect int. And then you do this, and you put a constant there because your conversion operator usually doesn't change the object. You're just converting, right? And then you just you return a rect int. So you go return rect int. And you go int top, int bottom, int left, int right. And that was how you would make a conversion operator to convert from any rect type into rect int. Let's do it. Now let's go back to our game, and you see it likes it. It likes it just fine. It's like, yeah, this is cool. We can do that. We're cool. Let me just build it. I want to make double sure. I want to make you double sure that I'm not pulling a fast one on you. Conversion operators work, and they're sexy. They're so sexy. Now let's try this. Let's try to convert from rect I into a rect F. Doesn't like it. Doesn't like it because we don't have a conversion function for that. See, it says it right here. No suitable user-defined conversion from our rect I to our rect F. Doesn't happen. Can't happen, won't happen. Because this one only is for rect int, converting into rect int. But what if we wanted to convert to rect float? Well, we'd have to make another one for float. Or is there a better way? Of course there is. We can make a template function inside of our template class, which is another kind of templateception. It's insane. We go template, and again class. We'll call this one T2, and then we go operator rect T2. So now the type the type that we're converting into is the template type, and it can be any type. Any type of rect can be the type we can convert into any type of rect. And all we do to convert into that type of rect is convert all the components to that type. So we just put a T2 in here, and look at that. Look at this, baby. Now this works. And if we flip it around, also works. Anything can work. I can make a fucking... I'm going to make you a special rect unsigned long. Is that a thing? I think that's a thing. Don't quote me on this. R long is equal to R1, and it still works. Good, it worked, because I wasn't sure it was going to work. So we can make any kind of rect we want, and we can convert from other types to that type automatically. It's like magic in my pants. Making them kind of tight, you know? Not quite tumescent, but, getting a little floppy is what I'm trying to say. Okay, I said too much. So yeah, that is making the template class. It's so good. And we're done. We are done with templates. Because we made our template, and it's good. Let's move on, people. Let's not dally about. Because we got work to do. We gotta scroll. This was the stuff that we got to scroll now. We got to do it. So how are we going to scroll? I'm going to put a bunch of bullshit on the screen right here. So I got an idea for you guys. I got a whole system. I got a whole design pattern thing that we're going to do. It's going to be so good. Let me just get my colors here, because I love colors. Okay, so we got, this is world's, dog. I didn't do it. Okay, so I hope nothing incriminating shows up when I do stuff here, because then I'm gonna scrap this whole video. Okay, nothing porn related has come up yet. I think we're safe. We can continue. All I gotta do is define my screen area here. Stop that. Stop it. Stop it. Okay, it doesn't matter. We'll go up to there. It'll be fine. It'll be good. It'll be good. Suck it, Wacom, and my screen capture bullshit. There we go. Alright, now I can... Okay, now I got full range of motion here. Let's... okay, so what was I saying? What was I doing? We gotta do screen... space. This is screens... I missed a letter there. Screen space. This is... viewport space, and this is... Oh, I fucked it up. Dude, I got it backwards. This is world space. This is view port space, and this is screen space. I must write the space out here just because. Getting all phlegmy. Okay, so cameras and shit. This thing here, this little rectangle, that's the wrong one. This one. This red rectangle, we call this the camera. And it has a position in world space. And its position determines what shit in world space appears in the viewport. Okay, so you move your camera down. What happens to this block? This is a tile map, by the way. And this is a block in the tile map. I'm moving the camera down. What's happening to this block in the viewport? Well, it appears as though the block is actually moving upwards. So first rule of cameras is cameras moving down equals shit moving up on the screen. Okay? So what you do is everything has a position in the world. That's like its position in the simulation of the world. Okay? Now that position is different than its position on the screen, right? Let's say the camera's down here. So here the thing's position in the world is maybe 50-50. But on the screen it's like at like -200, -200, okay? So you have to go, if you want to draw shit, you gotta transform its position from its world position onto its actual position on the screen, or in this case in the viewport. How you do that is you take the coordinate of the camera. So we'll say viewport X is equal to object X minus camera X. And likewise, viewport Y is equal to object Y minus camera Y. Because think about it, camera's moving down. Dick. Never mind, I'm just gonna leave it. Camera moves down, shit moves up. So a bigger value of camera Y equals a smaller value of object in viewport. So we're obviously subtracting the camera's coordinate from the object's world coordinate to give us our object viewport coordinate. So you do that, you get your coordinates of your thing in your viewport. So what do you do then? Well, you got your thing. Let's just let's move this down a little bit. So you've got your thing being drawn in viewport space, like this, I guess. I don't know. Whatever. Now you've got to transform that. Let's just do this. This gets transformed into this. This one gets transformed into this. Now you got to transform that to its actual coordinates on the screen, on the actual screen or on the window or whatever it is. The physical thing that you're going to render the pixels to. Now a viewport is an interesting little thing. A viewport, you can have a viewport inside of your screen, so you can have multiple viewports displaying different things at the same time, or just one viewport that's offset from the center of the screen. I don't know. Let me show you. Pictures are worth billions of words, right? So here's a game thing, old game thing. And it has a viewport where the game is happening, and then it has other shit and displays and crap like that, you can see. So you don't have to display to the entire screen. You can carve out a little piece for it and call that your viewport that you're going to render to. And that gives you more flexibility. Look at this. This is Shadowrun, right? It never rendered, I don't know why, but it never rendered to the edge of the screen. It always had this little box in the middle. This is kind of like off-center. I should have moved this window into here when I showed you, but I didn't. This is the thing I was talking about before. Okay. So yeah, like Shadowrun here, it's got this little weird box around the video, and it doesn't go all the way to the borders of the screen, which I always thought was kind of weird, but whatever. Maybe it's because like old televisions, they never really displayed all the pixels. They had this weird bendy thing that, I don't know. You guys are probably too young to remember those televisions. Anyways, so viewports, they're kind of cool. They let you offset. So if you're drawing to a certain position on your viewport, you actually have to offset that by your viewport's top left coordinate in the screen space in order to get the place where you're going to draw it on the screen. So here, you're basically subtract camera XY. And here, you add viewport XY to get your final position on the screen here. And the other thing you want to do when you're drawing is you want to clip that bullshit to your viewport. You don't want to be drawing outside the viewport. There's no point in having a viewport if you're not drawing within the viewport. So you want to add your viewport XY to the position, and you want to clip to viewport rectangle. So that's how you do it. This is welcome to the slam and welcome to the jam. So we got 3 kinds of space we're talking about: world space, viewport space, and screen space. You translate or transform from world to viewport, and then from viewport to screen. Obviously, if your viewport is the size of the screen, there's really no difference. Like, you don't really need a viewport then. You're just using the whole screen. But we're going to use the viewport concept here because it'll give us more flexibility. And because I wanted to show you it, it's kind of cool. I had this idea and I was like, this is cool. Let's do this. Let's do it. So we're going to use 2 objects. We're going to use a camera object. And the camera object represents your camera in world space that will translate to viewport space. And then we have a viewport object, which is going to represent your viewport as it sits in screen space. And it will translate coordinates from viewport space into screen space and clip them to the viewport rectangle. This is how we do. Let's do. Okay, so now I'm totally not going to pull up another window of Visual Studio that has all the code already written, basically, to look at. Like, kind of like a cheat sheet. I'm totally not going to do that. I totally didn't do that right now. Let's continue. So we need a new item. We're going to call it camera. Our camera obscura. Pragma wants. I guess you want a hashtag there. Hashtag Pragma. Pragma wants. What do we want here? Include rect and other. Also drink water. Pardon me. Delicious. Okay. Where was I? Yeah, making stuff. Okay. Camera. Class camera. We're going to want some publics and some privates. Okay, what do we want for public? What do we want for private? Float X, float Y. I think that's a gimme. Camera's going to need an X and Y. We're going to need some functions. Now, here's the thing I didn't talk about, and that is we're doing this transformation. How are we going to transform this bullshit? Well, how we're going to do it is in our present situation, we've got a thing going. I'm just going to undo all this bullshit. Wait a second, I got to undo it all. Undo faster. Go, go, go. So our present situation, let's see if I can talk while I'm doing this, is damn, I can't do it without my fingers moving. Okay. We got for example, we have a tile, right? Tile object, call it T, and we call t.draw, and we pass it graphics, and then the body of t.draw graphics, what it does is it calls put pixel to our graphics that we passed it. Put pixel into the graphics. Wow, this is really illegible. Anyways, that's how we do it, but that's not how we're going to do it from now on. Now what we're going to do is we're going to go draw camera, and we're going to do, we're going to call draw filled, no, draw solid rectangle, and we're going to call that on cam, which then calls that on viewport, which then calls that on graphics. So we got a whole chain of command here, and every step there's going to be a transformation happening, and finally at graphics all the work will be done. So we're relegating all the heavy lifting to graphics, and no one else touches the put pixels. Everyone else just does high-level calls like draw solid rect all the way. You'll see when we do it, but that's the basic idea. Same thing for surface. So a little bit of a shake up there. It'll go good. It'll go down nice and smooth. So we need a function draw solid rect. Draw solid rect. That's fine. Alright, now it's time for me to not look at my cheat sheet. Totally not. So, we need rect F, which is the rectangle to be drawn, and a D3D color, that's the color. And this will be const, because we're not changing the actual camera by doing this. Now what I want here we don't absolutely have to include this, but yeah, I like to include it because I got the color here. The D3D color. So why not? Next one, void. Draw surface. Alright, so what do we got for our draw surface? Let me not consult my cheat sheet. So we do D3D color pointer to pixels. So we're just going to pass around that pixel array, and that's how we're going to do it. That's how we're going to do. Could do it other ways, but this is the way I chose to do it whenever I thought of stuff. I probably thought a lot of this up while I was in feverish delirium. So just saying that int height float x float y. Lots of parameters. There we go. So we got these two draw functions that will be used in the camera viewport graphics drawing chain of command. What else? Well, we're going to need to be able to move the camera. So let's get in here a void set position float new X, float new Y. Now here's the thing. Here's the little thing that I'm going to talk to you about now. It just so happens that I hate all of you. I hate you all. There we go. Good. Okay. Like I was saying, it just so happens that for the purposes of calculation, it's nice to have your the position of your X and Y position be based on the top left corner of your camera. For just the purposes of calculation, it's easier that way. Doesn't matter. But for the purposes of using the camera, the actual camera interface, it's nice to have the camera seem like it's being like it's based on the center of the camera. Because generally, when you point the camera at something, you point the center. You don't focus on something by putting it in the very corner. Like, that's dumb. You'll put it right in the middle. So here's how we're going to do it. X and Y in our private variables here are going to refer to the top left corner of the camera, but the set position values that we use are actually going to set the center of the camera. So we're going to have to do a little transformation between center and top left. So from the perspective of the user of the camera, the person who actually moves it around, it looks like the camera is based on the center, when actually, in actuality, it's based on top left corner. But I'm not going to implement this right now because I need some other stuff that I haven't done yet. So we got a good little skeleton for our camera. Let's move on. Add new item. Now we add our viewport. Viewport. Hashtag pragma, hashtag game changer. Once. Pound sign include. Rect. Camera. D3D. Lovely. Class viewport, again with the standard bullshizzle. Private. Okay. So viewport is gonna have a rect I that defines the actual port in screen space. It's also going to have what? It's also going to have basically the same bullshit we had before. Let's go back to camera if we can. It's going to have this. Let's go forward. Yeah. I did it. We're going to have another draw solid rectangle and draw surface. Only in this one, it's going to be an integer for the solid, because now we're in viewport / screen space. And viewport / screen space is all about pixels, which don't have anything to do with floats. They don't care about floats. So we use integers for when we hit viewport space / screen space. So this is also going to be an integer. That's one of camera's jobs, is to convert from ints into floats. I mean, from floats into ints. Yeah, good job. And yeah, that's about it. I can't think of anything else at the moment. Yeah, that's fine. That's fine for a start. We'll get back to you later. Now, copy this, and we're going to go into our framework, D3D graphics here, and we're going to add these functions. Not constant in graphics, not constant. here. Now it doesn't know what rect I is because we don't have rect. So we'll put rect in. And yeah, that is good, not good enough. Now, we're going to need one extra parameter for when we actually draw it, and that is a rect I clipping box. We're going to need a box to clip to, and that is provided by the viewport. So rect I clipping, I messed that up. Clipping box. Now this is actually, we don't have to change this. We shouldn't change it. We shouldn't touch it. Don't touch it. So we'll just make that a constant reference. And that way we don't have to pass it by value. We don't have to copy so many variables. It's all good. Okay, so now we have our basic skeleton set up in our chain of command. Let's go back to camera and flesh things out. So camera has to pass on to viewport, so it needs a reference to viewport. So we go constant okay, I did this wrong. Viewport, where is it? Where's viewport? Does not include camera. It doesn't care about camera. It doesn't know about camera. Camera is the master of the viewport. So camera knows about the viewport because it has to have a reference. Viewport port. Alright. One thing that I wanted to add to viewport, but I didn't, is we need a couple of simple data functions here. Get width. Fuck you. And width is going to be, we're going to make it as a float because the thing that's going to want to get the width is the camera, and the camera likes floats. So this is return float port dot right minus port dot left. Float get height const return float port dot bottom minus port dot top. There. So this will give us our height and width of our viewport whenever we desire it. There we go. Now we go back to the camera. So let's do our set position bullshit here. We set position by x equal to new x, but then we have to convert that into from center of screen to top left position. And how we do that is we subtract half the width and half the height. So we go port dot get width divided by 2.0f. And y is equal to ny minus port dot get height divided by 2.0. And there you go. There's our position all set up for now. Foreshadowing. Let's do our drawing functions, shall we? So, draw solid rectangle. All we got to do here is we go rect dot translate. Now here's the trick. We got to translate negative x and negative y because remember, moving the camera down moves shit up on the screen. It's the opposite. So you've got to translate in the opposite direction as the position of the camera. So that's why we use negative x and negative y. It's tricky, but I know you can handle it. And then we go port dot draw solid rectangle, and we pass our rect, which will get automatically converted from rect f into rect I for us, and we pass our color. Okay, that was super simple. Wait, I got it. I got this one.
That was easy.
Ha ha ha. I got that from Christmas. My mom loves corporate humor. Okay, so now we do port.draw surface pixels width height, and here we gotta translate our x and y, so we go int x minus this pointer to x and int y minus this pointer to y. Yes, thank you, you're too kind. And I think that's not good enough, apparently. This would be a problem. How would you like me now? Still not good enough. Am I missing something? It probably wants the key. How you like me now? Okay, good. So there we go. Simple. We do the translation and we pass the buck on to our viewport. Last but not least is we actually need to make the camera. So let's do that bullshit. Const viewport ampersand port const. No. That's all we need. We just need a viewport. For now. So we go port. And let's be cool about it. Let's we'll just set position, I don't know, 0, 0. Doesn't matter. So we'll center our camera on the top left corner of the world. It's better than just having it in any random position, right? So there's a camera constructor, our two rendering functions that we need, and our set position function, and we are all set for camera. Let's move on to our viewport. Okay, so we got a width and height thing already set up. We're going to need in here D3D graphics. We're going to need a reference to the graphics. Now let's do our shenanigans here. So we go rect.translate, and we use the top left corner of our port as the amount to translate by. So we go port.left, port.top. Translate by that much. Right? You're following me, right? Because you got to translate by this much and this much to go from just normal viewport space into screen space. Capiche? Alright, and then we go graphics dot draw solid rect error. Okay, we'll ignore that thing that says error because that's probably fine. Color and then we need to send the clipping box, which is just our port. That is the clipping box. Okay. Continuing on. How do we do this? Same way, pretty much. Let's be sneaky about this one. We're gonna go back here. Copy this. Go back here. Paste it. Delete that thing. Draw surface. Okay. So we want to subtract from x port dot left. And by subtract, I mean add, of course. And we don't need to do this conversion to int bullshit because it's already ints. It's all ints. We're all ints here. We're all ints. No need to get all those conversion things out. Port dot top, And we need the port itself to clip to. Why don't you like it? Ah, because it's not port, it is graphics. And now we have, now the circle is complete. Almost. We'll go viewport. We've got to initialize this mother trucker. The motherfucker. Let's not. I'm totally not looking at my cheat sheet, which I don't have open right now. Graphics. D3D graphics. And we need constant rect_i port. We need actual rectangle to initialize our port with, and we go graphics port, and that is all constructor over. Alright, so there we go. That is our viewport completed. Now comes the fun part. Why don't you like my rect_i? I know why you don't like it. It's because you're racist. Wait, okay, it's fine now. Never mind. We're cool. So now we gotta actually, gotta, what's the word I'm looking for? Definition. We gotta define these functions. So we'll put them somewhere likely. Right after put pixel. Yeah. I don't know. I'll put it right here. Put her there. Okay, so let's do D3D graphics. Get our scope thing in there, whatever you want to call it. I forget what it's called. Whatever. Now we gotta draw this. So here unto hither, the rectangle has been drawn from the tile class, right? With where is it? Where's the draw? Where did you put my draw? I'm not. What did I do? Tile? Yeah, here we go. Draw. Okay, it's over here. Tile. Yeah, here we go. So we got to use this thing somehow. Let's go back. We got to use this, but we also have to clip to the clipping box, and we've got to draw this rectangle. So we need to change some things up. First of all, how to clip to the clipping box. Well, clipping is actually a pretty common operation. So let's be smart and put it in the rectangle class to be used by all from here until eternity, which is a really long time, I hear. So we go void clip to, and we'll just do a rect, I guess. Constant rect. Now clipping to something is very simple. We'll use maximum and minimum. We do top is equal to maximum of top and rect.top. Right? I'll explain this one case for you. Let's say we're clipping let's say we're clipping this rectangle to this rectangle here. So they both have a top, right? And we're clipping this one to this one. So obviously this one is going outside of the top, so you want to take the one at the bottom. Whereas if it was going down here, it would be within the viewport, so we would take this one. So you always want to take the one that's lower, and the one that is lower is the one that has the highest value. So you take the maximum of the clipping rectangle and the rectangle to be clipped. Whichever one is bigger, that's the one you choose. That's how you clip. Bottom is equal to the minimum of bottom and rect.bottom. I think you see a trend manifesting itself here, so I'm not going to explain them all on a picture. Left rect dot left, and right is equal to min right rect dot right. So this function, if I am not mistaken, will allow us to clip a rectangle by another rectangle of the same type. I don't know if it'll allow different types. It might, but whatever. I'm only guaranteeing same types, and I only recommend same types. So there we go. Now we have a nice little clipping function that will clip one rectangle to another rectangle. Let's go back to the future. Here we go. So now we want to clip. So we go rect dot clip to clipping box. And now we've got to use this rect to draw our rectangle. So we go rect dot top, and as long as it is less than rect dot bottom, we increment. Rect dot left, and as long as it is less than rect dot right, increment. And of course, we don't need to use graphics because we are graphics. We're the motherfucking graphics, bitch. So that's that. And that is draw solid rectangle done. Clipped and served, my friend. Now, let us proceed on our merry little way to our draw surface function. Now, draw surface is, of course, currently implemented in Surface. Maybe this one? Yeah, it's in the header file. So we want this bullshit. We want you, asshole. That was uncalled for. I apologize. Okay, so we want to shift tab that mother. Okay, so now we gotta somehow get this shit clipped and served as well. So clipping requires rectangles, but we only have width, height, x, and y. So we need to create our rectangle. We'll just call it rect because I'm original like that. And I believe it is top, bottom, left, right. So y plus height x plus width. For top, bottom, left, right. There is our rectangle. Now we want to clip this mother. So we go rect.clip to clipping rectangle. Okay, so now we have our clipped rectangle, which is the destination rectangle on the screen. That is important to keep in mind. It is a destination rectangle. Why? Because I called it clipping box here. Sorry. Didn't call it rectangle. I called it box. Okay, well now what do you want from me? Huh? It's a fucking... What? Clipping rect is undefined. Clipping... Okay, now something weird is happening. I feel like time is slipping sideways. I'm going to build this. See if it goes away. It's not going away, is it? Well, you go to hell. And also... Okay, now it went away. Good. So my IntelliSense is just fucking slow as balls. Continuing on. Okay, so we got... This gives us our destination rectangle, which is different than the rectangle we're going to use to draw from the surface, right, from the pixels. So we got to think here. We got to put on our thinking caps. Y start, X start. So X start and Y start, these are the start positions in the actual surface. And we will get those positions. See, we got this rectangle originally by adding height adding y and x to width and height to get our rectangle right. So if we subtract y and x, we will get our source rectangle back, sort of. Let's do that. So rect dot top minus y, and rect dot left minus x. See, think about it. Let's think about it for a second here. Let's not get crazy. Let's think like civilized people sometimes do. Not very often, to be true. To tell you the I don't know, the bald truth, the naked truth. People don't think. Take it from me. Okay, so you've got a rectangle for your surface. No, that's not good. You've got mail. No, you've got a surface. Fuck. I don't like it when it's all fucking, crooked and shit. I'm a perfectionist. Okay, so you got your fucking thing. You got your bullshit. Yeah, it's fine. Then you've got more bullshit on top of that bullshit. Bear with me here. I'm getting to a good explanation here. I'm explaining things because people like it when I explain shit. They're like, Chili, you always explain shit, and that's cool. So I say, hey, I'm going to keep explaining shit. So you've got your pixels in memory, right? So they have a position of 0, 0 here, and let's say it's, 50 wide and 100 tall. So this would be not 50 and 100, it would be 49 and 99. Okay? That's your fucking sprite in your memory, in your surface. Now here is your logical, fuck that all. Here's your logic, no, you're doing so good, and then you had to fuck it up. What the fuck are you doing? Okay, let's pretend that there are numbers here, but they aren't. Wait, now there are. 99, 49. Okay, now let's hope I didn't fuck anything up with the layers. Good. Okay, so you've got your surface. You've got your fucking dude. This is your logical rectangle of this surface in world space. Then you move your screen, your camera, so that part of your dude is in world space. In your viewport space. Then you're going to clip your dude here to this rectangle here. Alright, are you with me? So this rectangle is going to be like 0, 0. And we clipped it, so it's probably going to be like, let's say, I don't know, like 29 and 79. Okay, so it's smaller than this rectangle. Now, if you just use this rectangle to loop through your surface, what you'd get is the top left-hand corner of your sprite. Like, let's say your sprite looks like this, dude. Looks like this. That's your dude. You'd get this. You'd get like him drawn like kind of like that on the screen. But you don't want that. What you actually want is you want something like this, where he's actually drawn like this, right? Because he's partway off the screen. So in order to get that, you've got to recreate the part of this that you want to loop through from your rectangle, your clipped rectangle. And how you do that is you you subtract your x and your y, because the x and y are currently negative, right? X and y in screen space or in viewport space are negative numbers. So you subtract them from this, and what you end up with is a rectangle that is like, now I gotta do math. What's 40? It's like 29, 49, and 79, 90. So it's like, no, it wasn't 29. It was just 20. Yeah, I did it. I did grade school mathematics. 20 and 49 and 20 and 99, which is what you want. You want this rectangle here. You want to loop through this to draw it on here. So in order to go from this, which is this, to this, you need to subtract this, which is negative. So when you subtract it, you end up adding it. Yeah. Did that make it way clearer? Because it probably didn't. I think it actually made me understand it less just by explaining it to you. No, isn't that fucked up? But anyways, that's why you guys subtract y and x. So if you don't understand it, then just kind of like play around with it for yourself. Like draw pictures and stuff. And don't draw pictures of dick butt, because that won't help. I mean, it would be fun, but it wouldn't facilitate your comprehension of this phenomenon. Yes. Okay. So now, y end is also going to be, what is it going to be? Oh, it's going to be rectangle. Wait, I'm going to check my cheat sheet because I'm not sure. But I think it's going to be like rectangle minus again. Let me make sure, because I want to fuck it up and then, like screw you guys over. I mean, I don't really care that much about screwing you guys over, but just a little bit, I do. Okay, yeah, I was right. Heh. Okay, so we do rectangle dot bottom minus y and rectangle dot right minus x. Okay, so there we go. And this gives us our start and our end, which allows us to use this loop without fucking around with it anymore. Now that we have transformed our destination rectangle into our source rectangle, we have to transform it back to a destination pixel when we draw it. So to do that, we go x. Oh, fuck. Okay, so we got x and y here, and then we got x and y here. That's not good. Let's go I, y, I, y, I, y. I, x, I, x, I, x. And we go I, x, which is index of x into the surface, plus x, which is the x position in screen space of the top left corner of the destination rectangle of the original unclipped destination rectangle. Yeah. I made it to the end of that sentence. I'm not sure if it made sense at the end, but I made it there. That's what counts. Surface is now pixels because of reasons. Oh, wait. Yeah. So this has got to be IX and IY. Good thing I caught that because I almost didn't. Yeah. I think we're good. Sort of. I have no faith in this actually. It's probably going to look like ass when it comes out. Why is Book Pixel not happening? Oh, okay, I got it. Yeah. There we go. We are the graphics. We have the Put Pixel. We have the technology. Let's do it. Okay. So that's our whole thing built. I mean, that's our whole chain of command implemented. Let's see if it builds without actually putting it into the program. Why did the output get so big? Stop it. Failed. I knew it was gonna fail. Spoiler alert. I know everything. Where is it? Syntax error identifier D3D graphics. Yeah. Okay, so here's a problem. Rect includes D3D graphics. And D3D graphics includes rect, which as we know is kind of a pain in the ass situation. Now we normally handle that kind of situation by taking the thing that needs D3D graphics, which is draw, and basically moving it into its own implementation file, moving it into a CPP file. Then we don't have to include D3D graphics here. We just do a for declaration here, and then we do the formal implementation in the CPP file. However, we can't do that in this situation because you can't split templates into a header file and a CPP file. It doesn't work. It's not good. It's not even not good. It's just not a thing you do ever. So, the way we handle this situation is by saying, fuck draw, we don't need it. Fuck it. There we go, problem solved. Yeah. Okay, because the thing is, fucking snot. Okay, succeeded. That was good. The thing is, right, like, our rectangle is basically thinking of itself as a client of graphics. But graphics uses rectangle as a fundamental type. So it's like, wait, which came first, the chicken or the egg? So the way to do that is say, no, rectangle is not a client of graphics. Rectangle is below graphics. Rectangle is graphics' bitch, is what we're trying to say here. So if we want to draw rectangles, we put a function into graphics saying draw rectangle, and we pass a rectangle as a parameter. That's how we're going to solve this problem. There are other ways of solving it, but I like this way because it's super simple. But for the time being, we don't even need to draw rectangles, so I'm just going to delete that motherfucker. Now, we built our thing. It works exactly the same as before because nothing has changed. We haven't actually put it into the whole pipeline. We've just kind of built the foundations. So the infrastructure, if you will. So now we've got to put it into the thing and make it ring. Why did I even rhyme that? That was stupid. I'm not going to edit that out either. I'm leaving that in. You can facepalm if you like. So now, we've got like a whole situation here of drawing stuff with graphics, and we got to change that into drawing stuff with camera. So we go here, we have graphics, we replace that with camera. And D3D graphics, no, camera, cam. And then we go to tile.cpp, and we go cam, and we go cam dot draw solid rectangle rect f. Yeah, about that. How do we get the rectangle again? What do we got? We have height, width, x, and y. Okay, so, and I bet there are ints too. So let's go float. Top is y. Float y plus height. Float x. Float, suck it. X plus width. Oh, we need more stuff. We need a color. Do we have color? Apparently we do. And is that it? Am I done? Can I go now? No. No suitable constructor converts from bleh, bleh. Okay, I got this one. Rect F. How are we now? Okay, we're good. We create a rectangle, we float a rectangle, we put the stuff in it, and we pass it to the camera. Okay, so that's tile handled. now is the fun part. We go to sprite. Sprite.draw. Where are you? Go to definition. Okay. So draw current sequence. Draw. And we're going to pass it X, Y direction and camera. Camera. Cam. Let's go back. This one should be camera. Cam. Include camera. There we go. Go forward. Now we gotta. Oh, damn. Now we go to by surface sequence, draw, and we replace this one with camera. Wait, first we gotta go here. And we replace graphics with camera. And cam. And we replace this one with cam. Surface sequence. Okay. So now we've got to visit our friend surface sequence. Where are you? And camera. Where's draw? Where's my draw? Camera. Camera. I might have been able to get rid of this with like a D3D graphics, but I didn't want to do find and replace because I know it's just going to replace a bunch of bullshit that I don't want to replace and cause me headaches. So I'll just replace it the old-fashioned way. Cam. What? Oh, okay. You don't like it because it's not. I gotcha. Let's go to surface. Let's fix it. We will fix the boo-boo. We will make it all better. Let mommy kiss it better. Okay. Draw a normal surface. Whatever. Wait. Ooh, that's no good. That's a problem because we only have in camera we only have implemented the keyed surface drawing. We don't have implemented unkeyed. So, well, whatever. We don't use this anyways. It's just a thing that I made to demonstrate a concept. But just in case, we're going to do cam dot socket D3D graphics. Yeah, we need to include that. We also need to include camera. Good. Interesting. Okay, camera. Drot. Did I say drot? I meant to say dot. Draw surface. Perfect. Surface. Now the key is going to be D3D color XRGB. And the red is 255. The green is 0. I'll make that ugly color that I hate. I think it's called chartreuse. No, I don't know what it's called actually. I forget the name. Width, height, X off, Y off. And yeah, that works. Okay, so basically just going to default to this color being the key. And if that color happens to be in your image, well, then you're fucked. You're going to have a fucking weird thing. You're probably fucked if you fucking if you use this function, so don't. Fucker. There we go. It's not important because we don't use it in this thing, but just to be sure, someone's going to use it someday and they're going to be pissed off. Okay, so keyed service. Here's where the money shot is. And the good thing is, because we've already typed it out here, we can just do this one. And we do, again, we do camera. Cam.draw surface. And this one is the key. There we go. So that is this one done. Surface is done. Surface sequence is done. By surface sequence is done. Done now. Next in the line was I guess sprite, which was done already, right? I did that one. I did it. So they're all done now. Now all we have to do is what? What do we have to do? What does Chili have to do? Chili has to add cameras and stuff to the game. So we go to game.h and we add a, well, include camera. And we add camera, cam, and we add a view port. But not in that order. Viewport needs to be created before camera because camera, yeah. First we need to create graphics, then viewport, then camera. Because that is the opposite of the chain of command. Most important gets created last. Yeah. Now we go to game and we go make the viewport. So we go port, and I believe that's just created with what? With, okay, so we need graphics and we need a rect I for the thing. Now comes the, I'm not sure exactly how to make the port. I think it should be 0. Wait, what was it again? 800 by 600, so 599, 799, but I'm not sure. Not sure about the logic of this one, so we'll have to see. And we make camera off of port. Good. And now we use the camera to draw everything. Why is... because tile map... Okay, I forgot one. Let's go to tile map. Draw. Let's go... Yeah, I'll put it in. Include camera. Don't really need to. It's in tile already. Camera. Cam. And then we go to tilemap.cpp. Don't you like all this refactoring? I know I don't. But it has to be done. Cam. And we do... Oh, we don't want to get rid of this. This is good. We just want to put cam in here. Yeah. So we draw all the tiles, even the ones not on the screen. Here. Bill, no. Go back. Go back to game. Game. There we go. Now it doesn't like graphics. It wants cameras. And we will give it cameras We'll give it what it wants. The insatiable tile map and player. Okay, so I think this will build. Now, whether it will crash or not is another question. I'm going to say it might not crash, but it's probably going to be fucked up. Didn't even build, so I was wrong. Even before I got started. Okay, where's the errors? Let me show. Where is the errors and all these freaking warnings? That's a warning. There we go. Syntax error. Identify. Oh, okay, this thing. This was the thing that I was expecting. Wait, no. I fixed that. Syntax error. Identifier rect. Missing types. Okay, good. Okay, yeah. So the thing is, I got rid of where's rect? Where's my rect? I got rid of the draw, which needs this, but I didn't get rid of this thing here, which I should have got rid of. That's the whole point of getting rid of that draw function. But I didn't do it. Okay, so now this should maybe work. And by work, I mean compile. I don't mean that it's going to like look good or anything. Actually, it looks exactly the way it should. You might be saying this is stupid, but remember, we set our okay, we got a gray pixel here, so that looks like my viewport is set up not correctly. But this is the way it should be, because we set the camera to 0, 0, and it's pointing right at 0, 0 in world space, right at the top left corner of the tile map. And it's not going to go anywhere because it's not tracking our character. So if we want to do it, then we got to do it. Words to live by. If you want to do it, then you got to do it. You can quote me on that. I don't mind. What was I thinking? Okay, so first of all, it looks like the viewport has to be set up to be 600 by 800. Now this should give us proper viewportage. Yeah, okay, now, wait. Now I can't even tell. What was it like before? Because I can't tell if there's a gray pixel in between, if that's just my eyes playing tricks on me. It looks like it's fine now. What if I were to... It's the $7.99. Alright, no, there's definitely something in the middle now. Okay, so, yeah, it's got to be 800. So that's thing number 1 taken care of. This is how you have to define your viewport. Yeah, that's definitely better. I'm going to say that this is the way it has to be. Yeah, that looks right. Okay, so, number 1 thing taken care of, viewport, maybe. We'll see. It might need to be some more fixing. Number 2 thing is we got to make the camera follow the character. Now, to do that, we need to get the X and the Y position of the sprite, but the sprite is not showing us its goodies. It's keeping them all to itself. So we'd have to create a get X, get Y. Or do we? The answer is we don't. Fuck that. I'm not giving you anything that I don't have to. We're going to do something called... we're going to chillify this. That's a technical term. We're going to do point camera at. Or wait. What did I call it before? Let's use the thing I called it before. Where's my sprite? Move camera to. Yeah, whatever. That seems fine. Move camera to. And then we pass it to camera. How do you like them apples? Yes. Yes, ma'am. Actually. Constant. Nah, I don't want to fuck around with that. I could make all these draws constant now that I think about it. Constant camera. But it's too late. That ship has sailed. I'm not going to go through all that bullshit and change it now. Fuck that. Fuck that right in the ass. Okay, so moving a camera to something, we just do cam dot set position core dot x core dot y minus 100 minus 80. Because remember, the x and y of our sprite is actually the feet, and we don't want to point to the feet of the sprite. I want to point to its head-ish area. So I'll move it up, like move the camera up by 80. Alright, so that's good. And now we go to game. Where's game? There. So we do collision, we do other stuff, and last thing we do is we go player dot move camera to me. And that should be good enough build. Alright, let's try this. Okay. So I kind of fucked it up a little bit somehow. I fucked up like the keying of this thing. It's not drawing exactly how I want it to, obviously. Tiles work fine, and as you can see, the camera works fine, but I fucked up the surface drawing somehow. How did I manage that again? I'm gonna have to look into that. I think I know how I did it. I probably used the wrong surface. I used the non-keyed one in the algorithm. That's how I fucked it up. Good on me. Good on Chili. But everything else looks really good. So let's fix that one little problem. Teensy weensy little problem. That is really stupid bad. So we go to our old friend Mr. Graphics. We go draw a surface, and we go if so we go D3D color source pixel is equal to this one if source pixel is equal to key is not equal to key. Do this. Yes, I'm putting in the brackets here. I know you don't have to, but I want to. Fuck off. Yeah, that should do it. Oh wait, I gotta put source pixel in here. Otherwise, it makes no sense for me to actually use it. This is kind of an optimization, which is not super optimized because caching will make the second access fast anyways. But whatever. I am doing it. Yeah, I probably shouldn't do it this way. Now I'm doing it this way. I have made up my mind. It may not be optimal, but gosh darn it, it's the way I've decided. You probably don't even understand what I'm rambling about. Okay, good, it works now. That's all that matters, really, isn't it? Shit working is what we are all about. Yeah. Okay, this looks good. It's so good. I want to rub it all over my body. So now we've got a dude who can, like, you know, scroll. The camera can scroll to the dude. So you know what we could do with this? We could make a way bigger map now. Because think about it. Like, I mean, we're not constrained by the size of the screen now. We are unconstrained. Our limiter has been unleashed. So what I'm going to do is I'm going to alt select a bunch of bullshit here. I'm going to get rid of this. Actually, I'm going to get rid of all of this. Alt select this, delete. Alt select this, copy. Okay, that didn't work. Undo. Wait, what happened? Oh, I made the font size smaller, bigger. How was it? I think it was this size. Okay, Alt select, copy. How do I paste it sideways? There we go, that worked. Okay, good. Now, normal select. Paste that. There we go. Oh, isn't that beautiful? That's so delicious. Why did I get rid of all of those fucking shit? Shit. Now I've got to do it all over again. My God. The tedium. Oh, I did it wrong. Okay, let's do it again. Carefully now. Carefully. Careful. Don't fuck it up. There we go. Okay, and then we do... Wait, this isn't the last one, is it? There's more. Of course there's more. There's always more. Then we do that. Nope. Wrong. We do that. There we go. Okay, so now we have a quadruple-sized map. Let's... I don't know. Let's do this. Yeah. Actually, let's just do this. Alt. No, wait. I'm going to select double here. Copy that. Then I'm going to select this one. Paste it. Oh, magic. It's magic. What else do I want to do? Well, I guess we could get rid of this. Copy that. I'm just fucking around now. I'm wasting all your times. That's okay. I've earned it. I have been super concise in my explanations. I know because I've done this already once before and it was way longer. I was already at like 2 hours before I got to this point. Okay. Oh, yeah. And we'll just do this. Copy that. Put it there. Oh, I totally want to make like a staircase. I'm going to make a staircase here. Alright, so I got to do... Wait, I know how to do it. I'm just copy. Control C. Now I got to paste. Paste. Wait, no. Paste. 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 Okay, I think that's good. Now I got to make like these two into spaces. Maybe this one too. Yeah, that's the ticket. Make one more. Just to be safe. I don't know how much headroom this guy needs. Yeah. Copy that. No, wait. That would be a bad idea. That would not be the good touch. 1, 2, 3, 4. Okay. Done. Level has been completed. The ultimate level of Stickman running. Okay. Oh. Wait a minute. This shit doesn't line up. That's bad. Let's do that. Okay. Save the day. Save the map. Okay, now we've got problems here. Kind of. Test map string.cpp. We'll go test map string.h. So it was map width divided by tile size. Now it's going to be map width is 800 times 2, because I doubled it, divided by tile size. Good. Now, that should just load by itself. I shouldn't have to change anything else. Let's see if it did it. Oh yeah, son, look at it. Well, we got levels going, man. This is a fucking level if I ever seen one. Ah, fucker. Fuck off. Fuck you. Fuck you, bitch. Oh, I can't jump. Can't jump or shit. Do it. Okay, dude. Do it. Oh, you dick. Ah, that was a dick move. I didn't make the jump. Oh, I didn't make that jump either. Okay, we gotta go up the stairway, man. That's the whole point of this. So we gotta get up that goddamn stairway. Give me that fucking stairs. Oh yeah. Oh, suck it, son. Wait, I can't get up. Yeah, let me up. Let me up the stairs. Fuckers. Yeah, I did it. Hey, like me now. Alright, enough of that bullshit. So, that is the camera and the other dumb shit done. Let's think here. What do I want to do next? Well, here's one thing I might not want to do. Let me tell you this. The camera right now is going outside of the space of the tile map. And it can do this because we're actually rendering the entire tile map every frame and just clipping out the parts that we don't need. But if you had a really huge tile map, like let's say 1,000 by 1,000 tiles, that's 1,000,000 tiles altogether. But it's not inconceivable. You could make a tile map that big with today's hardware and memory sizes. But if you had a tile map that huge, drawing every tile, even though you'd only actually draw the ones on the screen, just going through the routines and clipping out all the ones you're not drawing would take a super huge amount of time, and it would be super dumb to do it that way. So what we do, generally, as civilized human beings who are wise in the ways of the C++, if I can just, fuck it, I'm not going to undo it, I'm just going to move this one. What we do is we do the same thing we did when we were doing the collision test. Remember the collision test? Do you remember the last 2 episodes? We didn't test against every single tile. We took the collision rectangle of the sprite, and we used that as the start and end points to loop through only a subset of the tiles. And we used that subset, and we did our collision test against only those tiles. Now we can do the same thing with our camera and with the world's not the world space, with the tile map. We can only draw the tiles which will appear in the camera and say "fuck you, shitlords" to the rest of these tiles, because they don't matter. But the problem is, if we do that kind of not drawing all tiles, just drawing tiles in the camera, what happens if we move the camera outside of the tile map range? Then we're going to go and try to find these tiles here, except we're going to go down here and be like trying to find these tiles, but the index will go outside of the array holding all the tiles, and our program is going to puke. So in a situation like that, it is imperative that we constrain the camera to within the boundaries of our tile map. So, and sometimes even if you don't need to, you want to do that just because it looks cool. So we're going to do that. We're going to constrain our camera into the boundaries of the tile map. That is mission number 2. And it's quite simple. All we got to do is go to camera and what we got to do here is, first of all, we're going to need a constant rectf boundaries. So this rectangle will show us the boundaries of our entire tile map. Where can our where can our camera exist in? And what we do here is we constrain our camera to the tile map. Boundaries. Yes. My brain is starting to shut down. Getting to that point here. 1 minute 44. Wait, 1 hour 44 minutes. Yep, it's about brain shutdown time. let's wrap this up before my brain melts out of my ears and pools onto the floor. So what we want to do is after we've set our x and y, we then want to make sure it's within our boundaries. So we go x is equal to the maximum of x and boundaries dot left. So we want x to be yeah. So if x, so let's say the boundary is our world space here. We want x to be, we're going to set our x position to be the bigger of this or this. So if it's bigger than here, we leave it as it is. But if it's smaller, we move x over to here. Good. I think that's good. And y is equal to the maximum of y and boundaries dot top. Now here's where it gets a little trickier. Not too much, but x is equal to the minimum of x and boundaries dot right minus port dot get width. We have to subtract the width from the port because the boundary for x, remember x is our top left corner, so we have to constrain x to here, which is this minus the width, and so that's why we have to do that subtraction. Capiche. Okay, and then we do y is equal to the minimum of y and boundaries dot bottom minus port dot get height. Yes, and there we go. We have constrained to our boundaries. Now we have boundaries, so we need to set them. So we go const rect f ampersand boundaries, and we go boundaries. There we go. And yeah, I'll leave set position where it is. If we do it this way, though, it's going to, after setting at 0, 0, it's going to quickly zoom to within the acceptable boundaries. But you get the point. Yeah, I think that's good. Now we need to set the boundaries. Now, what are the boundaries? Well, the boundaries are determined by the tile map. So we can go to tile map, and we create a function. We're going to call it rect f. Yeah. Okay, so we got a rectf get boundaries. And what are the boundaries? Well, return rectf. So the boundaries are going to be 0.0 because our tile maps are, the left and top are set to 0. So top is 0. Bottom is going to be height times, that's the height as in the number of tiles, times yeah, I don't think I can get height and width out of these guys because I made it. That's not good. So it looks like I'm going to have to expose this after all. Set width and height. Yep, I'm going to have to expose it. Okay. It's time for a little, what's the word I'm looking for? Static Wait. Int. I don't know if const even makes a difference. Make it const, I don't know. It might make a difference. Return width. How's that? Doesn't like it. We're gonna have to get expositional here. I guess that's what I'm trying to say. Expositionist. Yes. Okay, const doesn't work with static, so fuck it. Alright, so static ain't get width, get height. Well, I tried to keep it private. I tried to keep you safe, but the gods would not let me. Unless I can do some other bullshit, but fuck it. Fuck the bullshit. I'm just going to say expose that bullshit. So get height and 0.0f and width times tile. There we go. How is that? Looks good to me. Yeah, okay. I'm fine with that. I am fine with the bullshit. I just thought of a decent way of getting around exposing these ones, but nah. You know what? My insanity can only go so far. So, yeah, now we got a function to get the boundaries. Now we go to our game. Where's our game? There it is. And we go here, camera. It's going to want something else. So we go t.getBoundaries. And that should allow us to set the boundaries for our camera. There we go. And now if you look, our camera does not go off into space. It stays at its maximum point there. It stops at the wall and lets us run to the end there. So that's nice. That is nice. That's good shit. So that's very simple camera behavior for you. Just keep the character at the center until you hit the boundaries of the world and then stop at them. Decent and workable. Very workable. These stairs will be the death of me. Yeah, there we go. Okay, so that's that. And I mean, there's like way crazier ways of handling the camera. Like look at Shadowrun here. Let's see if I can get to a place where we're in the corporation. Yeah, something like that. Like the camera's kind of lazy. You could see the character moves and then wait, why am I wearing whatever. Character's like moving around like this. The camera's kind of following. If I could just stop for a second. This is a bad portion of the video to choose. Stop it. There we go. Why won't you stop? I'm trying to illustrate a thing here and you fucking the camera here is kind of like a lazy camera in that it doesn't just automatically zoom to the point where it's going. It kind of scrolls there. But it's hard to illustrate that point until I hate you. I hate you, video. You are not a good instructional tool. There's got to be like a thing here. Yeah, see, look at that. Did you see that right there? That's the thing I was trying to talk about. See, look, it goes, she stopped, but the camera keeps moving even after she stops. Kind of like zooming. It's kind of a lazy camera. I'm going to call it the lazy cam. So that's another way of doing camera that's a little more complicated. There's lots of ways you can do it. And you can make scripts for like when you have events and stuff like that. The camera can pan around. But this is the very simple thing. And, it looks good. I think it looks pretty good. It's a very simple, smooth. It behaves the way you would expect the camera to behave. It's basically all you need. If you want to get fancier, you can do it, but you know, this is simple and it works fine. So that's enough of my rambling about that. One more thing, we created this nice little port here. Why don't we try to use it? Why don't we just we're gonna constrain our thing to 200. 200, and this one will be let's see here, 200 to 600 is 400, so this one will do 200 to 500. That's a nice 4:3 ratio, right? Wait, but the 4 and 3 are backwards. Shit. This one should be 500. This one should be 600. So we're going to get a nice 4:3 ratio on our camera here. See, now we have a really small viewport. Now it kind of looks like ass because the background and the non-viewport space has the same color, so it looks weird. Like here, you don't know if it's just like you could jump like off the edge of this dick or if there's an actual wall up here. You can't really tell. So what we're going to do is we're going to put some rectangles around our viewport. Except we can't draw rectangles because we don't have the technology to draw rectangles. So we're going to go into, where is it? D3D graphics here. It's a little bonus. Think of this as a little bonus here. Chili is showing you how you can use your viewport for fun and profit. View void draw rect I rect. This one is not going to be clipped because it's just too much work, and besides we're going to be using this in screen space, so just to put a frame around our viewport, so fuck it. D3D wait int R, int G, int B. I did this for reasons. You'll see. So we'll go over here. D3D graphics.cpp. Just put this anywhere. Draw rect. It's getting really fucking cold in my room now. I'm gonna have to turn on the old heater. It's gonna make noise. Better finish this before I do it. So we go. We want to draw a rectangle. We want to draw 4 lines. So we go draw line. 4 times. And RGB. So we want to draw from x1, y1, x2, y2. So we do rect.top. No. Let's not do that. Let's do rect.left. Rect.top. So we go from top left to top right. So rect.right. Rect.top. Alright, so top left, top right. Then we're going to go from top right. Ugh, I don't want int. I never want int. Ever. Never, ever. Yeah. I don't want an iRect. What am I, fucking Apple computer? No, I'm not. Rect top to rect.right, rect.bottom, and then we want to go from rect.right, rect.bottom to rect.left, rect.bottom. And then we want to go, I don't know, we'll just do this one. Left top to left bottom. How's that? How do you like those apples? That seems fine. Let's build it. Fingers getting cold, man. Dang old fingers getting dang old cold. Wait. Why is there an error? There's not supposed to be an error. Oh, okay. Yeah. That is also not acceptable. Not acceptable. I would find and replace you with empty space, but that's just too much thinking. I'm just going to do it this way. I'm going to do it the dumb, slow way. I'm too hungry and cold to think. Why do you not like this R? Too few arguments in function call. Draw a line. 4 numbers and 3 color numbers. What do you want from me? Draw line. 1, 2, 3, 1. Why? Int R. Rect int. Error. Too few arguments and I don't even know anymore. I'm just gonna leave it. I'm gonna say that IntelliSense is fucking me over again, as it is wont to do. Yeah, it worked fine. Okay, so IntelliSense is just fucking with me. Okay, thank you for that. Now I want to draw my my little frame around my thing. So I'm gonna go to game. I'm gonna go here. Graphics.draw rect. Rect I. Okay, so the dimensions we're working with here are 200, 500, 200, 600. So we want maybe, I'm not really sure, 200, 500, 600. This might need a little massaging. Red, green, blue. What do we got? Make it black? Black seems fine. Wait. No, but the tiles are black too. We could make it a dark blue. That would be 0, 0, 128. Kind of dark blue. Yeah. Let's build that. See how that works. Seems alright. Yeah, that's fine. That's good. I was going to draw more rectangles, make the border thicker, but fuck it. This is fine. I like it. So here we go. So here's that's how you do like a viewport. That's how viewports work. You could use it for fun and profit, I guess, but usually you're just going to want to use your whole screen. But it's there. The functionality is in there for you if you ever desire it. So now let's look at thing. I wrote notes here about stuff I want to cover, but I can't read them now. Yeah, I think that's good. I think we got it. I think we got it covered. We are solid. We're gold. We're good to go. Ah, this is way too small. I want to make it bigger. So let's go for 10. And the bottom would be 590. Yeah. And here is 10 and 790. And we go down here. 10, 10, 590, 790. There we go. Okay. Now we got it. Yeah, now we got like a weird port thing. That's just like Shadowrun. But this game's practically Shadowrun, isn't it, for the Super Nintendo? Almost. Except it's a platformer. And there's nothing. There's no game. But besides that. So, here's the part of the video where I ramble on. Let's try not to do too much of that, because I want to eat. But yeah, this was scrolling and stuff. And also templates. Yeah. That was good too. We had fun, didn't we? We had some times. But now our time is about to come to an end. And let me just tell you, spoilers here. There's going to be a really ground-shaking announcement about the tutorials, intermediate tutorials, the platformer here, coming up in the next video, which will be in about maybe a week, maybe a little less, maybe a little more, around a week. That's my time frame. I'm going to make a little video. It's going to be an announcement video. It's going to blow your mind, man. Or maybe not, whatever. But, yeah, so look forward to surprises in the next video. As for this video, I think I'm about to call it a wrap. And, yeah. If you've got any questions, comments, you want to tell Chili how swell a guy he is, you just come down, mosey on down to the forums, pay me a visit, and if not, then I guess I'll see you in the next video, which will be super exciting. So count those sleeps until the time that I did not specify, but count them anyways. Goodbye.